So my name is Arash. I have sort of a double role. I work part-time for Alana. So I'm head of linguistics at Alana. I'm also a lecturer at Heriot-Watt University. So a bit about Alana. First, I'd like to thank Mike. He's already introduced us. So Alana is a spin-out company of Heriot-Watt, and specifically the Interaction Lab, led by Oliver Lemon. We took part in the Alexa challenges for 2 consecutive years in 2018, 2019. We were twice finalists, came third, but the guys did really well. I was faculty advisor in the second round of the challenge, and that's where the company has basically emerged from. The background IP that we started from was from the challenge. This is joint work with Vivek, who has helped implement some interesting models that I'm going to talk about. So you might already be wondering why the weird title, maybe tautological title, right? So conversational natural language understanding, you might be thinking natural language understanding, of course it's conversational, right? And the answer is no, it usually in fact isn't. So what I want to emphasize in this talk is the collaborative, interactive nature of understanding in conversation. So from psycholinguistics, from 30 years ago, it's very well-known fact that people actually put effort in understanding each other. They monitor each other for understanding. Things can go wrong and they fix it, and they do this through explicit interactional effort, okay? Miscommunications happen. Even if miscommunication doesn't happen or they fully understand each other, they give each other positive evidence of understanding. So it's a two-way thing. Unlike a lot of architectures for natural language understanding that we see that are unilateral. So you receive some input from the user, some utterance from the user, or some turn. You put that through. You come up maybe with its intents, the entities, and so forth, right? And then the system acts on that. Okay, and the system acts on that, assuming that it's understood the user. But that's not, that can turn out to be the wrong assumption on the part of the system. And so what kinds of architectural changes would we need to make in order to enable this sort of collaborative aspect of natural language understanding in our dialogue systems today? And that's mainly what I'm going to be talking about. So there's a concept that was introduced by Herbert Clark in 1996, and the concept is called communicative grounding. He called it grounding, but to distinguish it from symbol grounding, which is another kind of grounding, although related, I've been calling it communicative grounding in conversation. Now, this is a simple process of interactively establishing understanding. I say something, you either give me positive evidence, you say, you nod, right, that you understand me, and it is only then that the conversation can go on, or something goes wrong, right? Something goes wrong, you don't understand the particular aspect of what I'm saying, in which case you will initiate some kind of clarification procedure, okay? So what things can go wrong and on what levels? So there is this concept of a grounding ladder with 4 steps or 4 levels. The first step is attention. So I have to get your attention. Alana needs to get attention of the user, and vice versa. The user needs to get the attention of, say, Alexa by using the wake word, right? So that's level 1. Level 2 is perception. So Alana has heard the user, right? I've heard you. That is, I could hear every word that you said. I could recognize each individual word in your utterance. The third level, so things can go wrong at any of these levels, right? At the level of perception, if things go wrong, if I don't hear you, if the environment is noisy, what happens is it might lead to clarification interaction. So I might say, pardon? Can you repeat that, please? Right? In the context of a dialogue system, conversational AI, this might be triggered by uncertainty in the ASR speech recognition hypotheses. And that's when you can recognize when to actually ask for clarification on that level, okay? The next level here is understanding. So Alana understands the user, right? How might that go wrong? Well, you might name a particular book. Let's say Lord of the Rings. Lord of the Rings is both the movie and it's a movie and a book, right? So what did the user actually mean? So that's something going wrong with establishing the reference of the Lord of the Rings. What kind of clarification might that give rise to? The book or the movie? And then the user might come back to you and say the book. And then the system takes an action based on that, based on Lord of the Rings, the book, rather than Lord of the Rings, the movie. Okay. And the fourth level, acceptance. Okay, you might request something. I understand you. I heard you. You made contact, but I might say no still, right? I might reject your request politely. Okay, and that's acceptance. For conversations to move on, all of these four levels need to be successful. Okay, even if I reject, that's grounding at the level of acceptance. I reject and then we go on. Still grounded. What was said was grounded. So, failure in the context of a dialogue system, sorry, or actually, this might be a child talking to Alexa, trying to buy something. Alexa understands it, but sorry, or actually, you don't have permission to buy this item. Okay. So, a little bit more about the things that can go wrong, because that's what we're interested in here. So an utterance is grounded when Alana and the user are both on level 4. Now, trouble or fault is possible on each of those levels, as we have already said. So perception, you didn't hear. You had ASR, the system had ASR uncertainty. At the level of understanding, it could be because it's an unknown word. It could be because you couldn't establish the reference of what was said. There are a myriad of reasons why you might not understand something, and that becomes really complex. And here we're trying to deal with limited cases, limited reasons for lack of understanding or misunderstanding. And trouble can be detected. We do it all the time. Trouble can be detected and it can be repaired. Repair is a term from a field called conversation analysis. Some of you, I'm sure, are familiar with it. And they've studied the systematic, very orderly ways in which people deal with miscommunication. So these repair procedures have been well studied in the field of conversation analysis. Emanuel Shegloff is one of the main proponents of this method. It emerged out of ethnomethodology. I would have loved to go into it, but there's no time. So we thought, okay, Alana can do it too, right? Of course, it's not that simple, but we've done some work towards it. So I'm going to use the term metacommunication. Metacommunication is communication about communication. It's asking about what you meant, okay? It's correcting something, correcting yourself, correcting the other person, correcting an intent. Maybe the NLU component derived an intent, but that intent turned out to be incorrect, okay? So we can communicate about that. What did you mean by that, right? So just to go through these very quickly, these repairs, these sequences which deal with miscommunication when it happens, they're very systematic. So there's one kind called self-initiated self-repair. So I'm in the car and I say to the car, drive to Ealing, Richmond. And the car needs to understand to drive to Richmond, right? In the middle of producing my turn, I have recognized that I didn't, in fact, intend to go to Ealing, but rather Richmond, because I was under time pressure to produce my utterance. In the second example, which I'm going to reuse in other contexts, who won the women's tennis tournament? The US Open. Alana says Emma Raducanu. Without that further qualification, tennis tournament is ambiguous, right? So the second case is when the repair is requested by the other person because they don't understand. So the user says, who won the women's tennis tournament? Alana says, which tennis tournament? User says the US Open. Alana says, Emma Raducanu. Okay? Now this is the middle bit here. The second turn is it's so-called a clarification request. It's also called the next turn repair initiator. The repair is initiated by the other person, but it is performed by you or by Alana or by the system. Okay? And then the user repairs themselves, the US Open. So this is similar to the previous slide, except interactionally, it's a different structure. There are these much more interesting cases where there is a misunderstanding by the system or the other person. So the user says, who won the US Open? Okay? And the system answers that question saying Emma Raducanu. This to the user reveals a misinterpretation because the user actually meant, no, I meant the men's single. Now these have been called third position or position 3 corrections within the CA conversational analysis literature. Then the system can correct whatever representations they had built in the first instance and answer the question accordingly. Okay, so the answer is then, oh, sorry, Daniel Medvedev, that there's a misspelling in Medvedev's name, won the men's single title. Okay. Now, Shegelov famously called this the last structurally provided defense of intersubjectivity. Because if we get past this point, miscommunications go unnoticed, and they will persist. Because, we've had a miscommunication, we never figured out that we had a miscommunication. Okay, so this is the last provided place to defend it. Defend your intersubjectivity with the system or with each other. Okay, so what have we done? So a bit about the underlying architecture of the Alana system. So much of what you see here is the same as what we had at the time of the Alexa challenge, but we've updated it in order to make natural language understanding interactive. So the NLU is not just a sequence of models that you might put a user utterance through, but NLU itself is a bot that tries to ground, tries to understand the user by interacting with it. So if it needs to ask for clarification from the user, it would do so. On the left-hand side, you've got a pipeline of components, modules for disfluency detection, corrections, anaphora, ellipsis, intense, named entity recognition, etc. Okay. On the right-hand side, you've got several bots. They work in parallel. They all process the conversation and all produce responses. So from here, they send responses to the hub. The hub ranks them, okay, ranks those responses. We've got both a data-driven ranker and a rule-based ranker, which is based on a priority list, that then chooses one of those responses and sends to the user. In this particular case, it is the conversational NLU component that is actually producing the response. So who won the tournament? Conv NLU goes back, which tournament? And the user responds to that. The user responds to that. Once that understanding has been established, once that miscommunication has been resolved, it is only then that all of the NLU annotations, including intents and named entities, are actually made available to the bots. So the bots are oblivious to this interaction actually having taken place. They don't know. They just rely on the representations that have been sent to them by NLU. Conversational NLU makes sure that those representations are correct and grounded before they are made available to all the bots for processing. Okay. This is the overall architecture of the conversational NLU component. Multiple modules. This is a modular architecture, modular pipeline. Not all relationships are serial. Okay. At the level of perception, in the very beginning, the perception check module looks at ASR uncertainty. If there is uncertainty in the ASR, it asks for clarification immediately. CR stands for CR generation, for clarification request. If everything is fine, the words go to the Disfluency tagger, which I'm going to talk about, and self-repair tagging model. That then goes to other kinds of repair classification and repair execution. Now note that if there is a repair, for example, one of those late corrections, then you're actually changing the representations that are in context. You're taking something out, slotting something in its place, okay? So all the processing that was done by all the subsequent modules on the original representation need to be rerun. That's the reason behind these dotted lines, okay? Because you've corrected the representation, and whatever processing they did for that previous representation turns out to be wrong. They need to redo all of that, okay? And that's triggered by the repair component. It comes back with the level at which that trouble occurred. So only the modules after that point need to be rerun. So n is the level at which repairs are made to the context, for example, in late corrections, okay? Repair execution means updated representations at level I. Update at level I means that all the modules from I onwards need to rerun, whatever they are. If you put it through intent recognition, it needs to rerun. If you put it into named entity recognition or slot tagging, that needs to rerun with the new representation. What that representation is depends on the module. It might be at the semantic level, at the meaning level, or at the utterance level, at the text level. Okay, so that's broadly what that is. So this has actually been implemented, and our system can produce these clarification requests at the moment. So user says, tell me about angels and demons. Conversational NLU comes back as a bot and says, sorry, do you mean the 2009 American mystery movie or the book by Dan Brown, which is a clarification request. The user says the movie. Alana says, oh yeah, I heard something interesting about angels and demons. Naomi Watts was originally cast as Victoria. So it's talking about the movie. So that's been implemented. How was it implemented? Note that angels and demons is ambiguous. We have to detect that ambiguity first. We do that using Wikidata ontologies. We look at whether we can, unnamed entity linking, whether we can link that entity to two separate documents within Wikipedia, within Wikidata. And then we find a property that distinguishes them. The property that distinguishes them is whether it's a movie or a book, the type of product that it is. Okay, so I talked to you about self-corrections and disfluencies. This is also part of trying to build systems that are robust. I have made a lot of errors when I was talking. I've produced lots of M's and R's. I've backtracked. Okay, I've corrected myself during this talk. I've paused a lot. Okay, so spoken language, because you're under pressure to produce it, is full of such phenomena. In fact, you wouldn't be able to find a completely clean sentence ever. Okay, not ever, but very rarely a sentence is completely clean. Okay, so how do you deal with that? How do you deal with this very fragmentary nature of spoken conversation? This is the general structure of disfluencies or self-corrections. They are part of the same category. Who won the or the football tournament? These are the tags. So the first bit, the tennis, is the referendum. It's what is repaired. There's something wrong with the tennis, and that is repaired. The interregnum signals the repair, okay, that the repair is upcoming, and then the football then is the repair proper. If you wanted the clean version of what the user intended, is who won the football tournament, okay? We can deal with that. So there's been a lot of work on disfluency tagging in dialogues, and I've been working, I worked on it with a PhD student of mine 3 years ago, but also I've been working with Vivek on it. The state-of-the-art model currently for tagging repair structure is Rohanian and Half, and we have built a model around that. The model is a BERT-based model. It's a transformer-based model. We've got a BERT encoder with a conditional random field layer on top of it. We include part of speech embeddings. I need to wrap up? No, still with time, but... Okay, yeah. So this model can be run incrementally, so word by word. We can tag the disfluency structure word by word as it comes. We've tried it on 2 separate data sets, switchboard and disfluency QA. The DisQA is a new corpus from Google, which is based on the Squad question answering data set. Switchboard doesn't include many self-corrections, so we were having problems with self-corrections. So the DisQA data set is helping with that. And we've evaluated both in a non-incremental context and an incremental context. So word-by-word tagging or whole turn, whole utterance, disfluency structure tagging. Results are very promising. We've managed to match the Rohani and half results, which are state-of-the-art. On switchboard test set, we get 91.7% sentence-level match, means all the tags are correct in the sentence. In the DisQA test set is more difficult and data is more sparse. We get 83.5%. On the combined set, we get 81%. These are the precision recall and F scores. They're quite high. They beat my own work with my PhD student 3 years ago by quite a lot. That's from the power of transformers, essentially. That was an LSTM model. Okay. There is ongoing work on smoother turn taking. So I'm working on a different sub-project with another researcher at Alana on end of turn detection. So when you're going to stop speaking, we don't like bots that are interruptive. Alexa is really bad, in fact. If you have a pause, it's going to interrupt you. Alexa, can you play Sorry, I Don't Understand You? I'm trying to think of a song, but it's broken off. So we're working on contextual resolution model for anaphora and different forms of ellipsis and fragments in a domain general way using a sequence-to-sequence T5 rewriter. That's already been integrated. Yeah. And 2 projects. So we're working with the Royal Institute for the Blind. We're building a conversational agent for the blind. And where Alana provides descriptions of the scene conversationally, but also it's able to answer questions in an open domain fashion. This is a recent project, EU project that we were funded for, yeah. Yeah. Sorry.